For this section, we'll be adding vectors. These vectors that we're going to start with is 4 with an angle of 20, added to 7 and an angle of negative 230. On the first one, I drew it in the first quadrant, as you can see here, and I ended up with a 20 degrees off of the standard. 4 is my radius from my given number. Once I do that, I go ahead and draw the other angle, which is a radius of 7 and negative 230. So I start at my standard point here, and I go negative 230 degrees. When I subtract that from 180, which is a straight line, I end up with a 50-degree angle internally on the triangle. I need to convert both of these because in order to add these vectors, I cannot add them because I have different radius and different degrees. So I'm going to convert each one of these into their regular form, I and j's, and go ahead and add them from there and then convert it back. The next step is that I go ahead and look at my first triangle here, and I need to find my x and my y. For my x, which happens to be my adjacent, and my known hypotenuse, I'm going to use the cosine. Cosine is adjacent over hypotenuse. The cosine of 20, which is right here, will equal my adjacent, which is my unknown x, divided by 4. That's my hypotenuse. Multiply 4 by both sides, and I end up with 4 cosine 20 equals x. I hit that in my calculator, making sure my calculator is in the mode of degrees, and that gives me a value of 7.76, or 3.76. That's the value of this x right here. I need to find y. Y is opposite to 20, so I'm going to use the sine function. Sine of theta equals opposite over hypotenuse. My hypotenuse is still 4. My sine is my opposite is unknown. So the sine of y over 20 would be y over 4. I multiply both sides by 4 and end up with 4 sine 20. I once again put that in the calculator to get 1.37. This would give me x value, I'm in first quadrant, both are positive, x value of 3.76, y of 1.37, or if I wrote it as i's and j's, 3.76 I hat plus 1.37 j hat. The next step is I move to my second triangle, which I'm ready to use, and I go back to 230, which gave me an angle of 50. I'm going to use adjacent, which is for x2, which is my second x I'm looking for, and I know the value of 7 as the radius. My cosine function is adjacent over hypotenuse, so I go ahead and put in adjacent, which is x2, divided by the 7, and get cosine of 50 equals x over 7. Multiply 7 by both sides, and I end up with 7 cosine 50 equals x. Use the calculator and get 4.50. I do the same function for the sine, realizing that my sine function is opposite. Y is opposite to 50. Opposite is 50. Opposite of 50 is the y2 and 7. 7 is a hypotenuse. Sine is opposite over hypotenuse. Y over 7 equals sine 50. Multiply both sides by 7, get 7 sine 50 equals y. Use the calculator and get 5.36. That gives me a value of negative 4.5. This is different than what I came up with here, which is a positive. And the reason is because I'm in the second quadrant. In the second quadrant, x is going to be a negative amount. It's going this direction here. Y is still going up the page, so it's still going to be a positive number. So y is positive, x is negative, and I go ahead and plug those into my correct format. Negative 4.5. and a positive 5.36, or if I'm using the I hats and j hats, negative 4.5 I hat plus 5.36 j hat. At this point, since I have an x and a y value, I can simply add my x values and y values. And really, I can look at this as either way. If I'm looking at I hats, I'm saying 3.76 plus a negative 4.5 for the I hats. The j's are 1.37 added to the 5.36. And that's going to give me a value of negative 0.74 I hat plus 6.73 j hat. Or if I want to look at it in just x and y format, it's negative 0.74 and a positive 6.73. If I graph that, that puts me into second quadrant. So what it's really telling me is when I add these two vectors together, this vector and this vector, the resultant vector is right here in this quadrant. This vector has an x and a y value that we know, but we don't want that in that format. We're looking for it to be in polar coordinates. So I'm going to take my x and my y. My x is negative 0.74, my y is 6.73. And I'm going to use the Pythagorean theorem, x squared plus y squared equals r squared. So get r by itself by taking the square root of both sides. That gives me the square root of x squared plus y squared. 0.74 squared, 6.73 squared. Add them, take the root, and I get 6.77. That's my radius. That is this length from here up to here. Now, that's great, but I still need to find this angle here. I don't know this angle, but I am able to calculate this angle. So I label it as theta, and I realize that I have y and x. X is my adjacent value, y is my opposite value. I have a trig function that works with opposite and adjacent, happens to be the tangent. So I'm going to say the tangent is opposite over adjacent, which is going to be the tangent of theta will be y over x. Well, the tangent of theta, therefore, is y, 6.73, divided by 0.74. Notice that I'm positive right here, even though my value is negative. I'm finding the internal angle, and so all the sides are going to be positive. That gives me, if I hit second tan of that on my calculator, I will end up with 83.73. But once again, that's this angle here. I don't need this angle, I need this one. Realizing that this is a straight line here, and that makes it 180 degrees, 180 minus this will leave me this value over here. So I'm going to use 180 minus 83.73, and that gives me 96.27. That's the angle that I'm going to be. 96.27 is the angle, 6.77 is the radius. So once again, I have used the resultant of these two vectors right here in vector format, which I cannot add them directly, converted them into rectangular format, added them, and then converted them back into my other format, which is going to be polar. And that was the answer.